Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The reactivity of an alkyl-substituted benzene towards EAS depends on the electron-donating ability of the alkyl group via hyperconjugation and induction. The methyl group activates the ring through hyperconjugation, which involves the overlap of CH or CD or CT sigma bonds with the aromatic pi system. Moving on to the next step. Identify the substituents. Compound ACH3, methyl with prosium H. Compound BCD3, methyl with deuterium D. Compound CCT3, methyl with tritium T. Moving on to the next step. Apply the hyperconjugation concept. Hyperconjugation involves donation of electron density from the CH bond into the aromatic ring. The effectiveness of hyperconjugation depends on the ease of CH bond ionization overlap, which is related to bond strength and the mass of the isotope attached. And for the final step, consider isotope effect on hyperconjugation. The CH bond is weaker and more polarizable than CD, which in turn is weaker and more polarizable than CT. This is because heavier isotopes form stronger, shorter, less polarizable bonds due to lower zero-point energy. Therefore, CH undergoes hyperconjugation more readily than CD and CD more readily than CT. Consequently, CH3A donates the most electron density highest EAS reactivity. CD3B donates intermediate electron density intermediate EAS reactivity. CT3C donates the least electron density lowest EAS reactivity. Arrange in decreasing order of reactivity. ABC. Why other options fail? Option B. CBA incorrectly reverses the order. Heavier isotopes do not enhance hyperconjugation. Option C. ACB incorrectly places CT3 above CD3. Tritium forms stronger CT bonds than deuterium forms CD bonds, so CT3 hyperconjugates less effectively than CD3. Option D. CAB incorrect ordering with no physical basis. Therefore, the correct answer is A. Therefore, the correct answer is option A.